Chandana, graduating from Srinivasa Ramanujan Institute of Technology, holding a roll number 234G18045. And today my topic is operation of solar power generation system from the subject Basic Electrical and Electronic Engineering. Let us see the presentation. Now, introduction to solar power generation system. Solar power generation systems harness the energy from the sun to produce electricity. These systems consist of various components that work together to convert sunlight into usable power. The layout and the operation of solar power generation systems plays a crucial role in their efficiency and effectiveness. Here you can see the diagram of solar power generation system. So sunlight comes from the sun. It is traveled to the solar panels. Here you can see the N-type silicon junction P-type silicon. When the solar panel receives the proton from the sun, electrons flow above the junction and the holes flow below the junction. From that, a current is passed. Next, see the main components of solar panel system. First, sunlight travels to the solar panels. These devices capture the sunlight and convert it into direct current electricity. From the solar panel, it is connected to the charge controller. From the charge controller to the battery and also the inverter. Inverter converts the DC electricity generated by the solar panels into alternating current electricity, which is used to power appliances. From the battery storage, stores excess electricity generated during the day for use during the periods of low sunlight or at night. From the inverter, AC load is traveled to the green powerhouse, and also from the battery, a DC load is connected to the green powerhouse. Now let us see the layouts of the solar power generation systems. First, orientation. Solar panels are usually installed facing south in the northern hemisphere to maximize sunlight exposure. Why these solar panels are tilted? Let us see. Tilt angle. Panels are tilted at an angle depending on the geographical location to optimize sunlight absorption. Spacing. Panels are spaced apart to prevent shading and maximize sunlight capture. Here you can see the diagram about this layouts of a solar power generation system. Here this is the um, panel. Here you can see the photovoltaic cell energy conversion, how it is converted from this converted to energy inversion under conditions. The energy is inverted to electricity. From this, some energy is distributed. That is, excess electricity can be stored for future use or sold to utilizers. And then it is sent to the energy storage. Electricity is sent to the batteries to power a building. From this we will get the electricity use, that is energy use. Electricity can be used as normal. This is about the layouts of the solar power generation system. And next, operation of solar power generation systems. Sunlight exposure. Solar panels absorb sunlight which excites electrons, creating an electric circuit. So this creates an electric circuit. Conversion of DC to AC. DC is the direct current and AC is the alternate current. Inverters convert the DC electricity produced by solar panels into AC electricity suitable for powering appliances. Net metering. Excess electricity generated can be fed back into the grid, earning credits or reducing energy bills. Next, types of solar power generation systems. There are three types of solar power generation systems, that is grid-tilt systems, off-grid systems, hybrid system. Now let us see what are they. Grid-tied systems. Connected to the electric grid, these systems generate electricity for initiate use and can explore excess power to the grid. And next, off-grid system. These systems are independent of the grid and rely on battery storage to provide electricity during periods of less sunlight. And next, hybrid systems. Combine both the grid-tied and off-grid elements, allowing users to switch between grid power and store solar power. Next, factors affecting solar power generation efficiency. What are the factors that are affecting? Now let us see that. Solar irradiance, temperature and sharing. These are the factors affecting solar power generation efficiency. Now let us see the intensity, solar irradiance. The intensity of sunlight affects the amount of electricity generated and how temperature is affected. Solar panels operate best in moderate temperatures and high temperatures can be efficiency. Now shading. Even partial shading on solar panels can significantly impact the performances. Next going. Now let us discuss how they are maintained. First, regular cleaning. Solar panels should be cleaned up periodically to remove dust, dirt and debris that can reduce sunlight exposure. If we do not clean regularly, it cannot absorb sunlight, so we should clean it. System inspection. Routine inspections are essential to identify any issue with the components and ensure optical performances. Next, inverter maintenance. Inverters should be checked regularly for proper functioning and firmware updates. What are the benefits of social power generation system? Let us see. These are renewable energy, so they are recycled. Cost is very less and there is no impact on temperature. Now let us see what are the challenges of solar power generation systems. Initial cost. The upfront investment for installing social power system can be relatively high. Intermittency. Solar power generation depends upon sunlight availability, making it intermittent during cloudy or nighttime periods. Space requirements. Large space solar power system requires a significant land around area for installation. Here you can see the solar energy cost compared from 2010 to 2009. It is decreasing year by year. So this is the graph of the solar energy cost. Last, what we conclude from the solar power generation system. Solar power generation systems are an effective and sustainable way to generate electricity from sunlight. Their layout and operation are key factor in maximizing efficiency and reliability. Despite challenges, benefit of solar power make it an increasingly powerful choice for clean energy generation. Thank you for watching my presentation.